Hi students, today let us learn homologous series. First, the definition. It is a group of organic compounds having similar structures and similar chemical properties in which the successive compounds differ by CH2 group. So in general, let us understand, or first let's take an example for alkane. So we all know alkanes have general formula CnH2n plus 2, where N is number of carbon atom, N is 1, 2, 3, 4, and so on. Now first if I substitute N is 1, then I get methane, that is CH4. Now the second member would be C2H6, that is ethane. Third member would be C3H8. Fourth member would be C4H10. Now if we look at the adjacent homolog, then we can understand that each one of them differ by CH2 unit. That is C2H6 minus CH4 would be CH2. Similarly, C3H8 minus C2H6 would be CH4. CH2. So this is a homologous series. So I can call CH4, C2H6, C3H8, C4H10 and so on as homologous series because they differ. First of all, they differ by CH2 unit, and the second thing is that they have similar chemical properties. All alkenes will have similar chemical properties, and they also possess similar structures because they are all made up of carbon and hydrogen, that is hydrocarbon. Now let us understand the third characteristics. Each adjacent homologous differ by molecular mass 14U. So if I take the example of CH4. Okay, what would be the molecular mass of CH4? Carbon is 12, oxygen is 4, so 16. Now the next homologous series, that is C2H6. C2H6 would have a molecular mass of carbon is 12, 12 2s are 24 plus 6, that is 30. So 30 minus that is CH4, 30 minus 16 is going to be 14, right? So like that, if you go on subtracting the molecular mass of the next homologous series with the previous homolog, then it would the subtraction would lead to 14, that is 14U. That means that every homolog, okay, is differs by the previous homolog by molecular mass of 14U. So that we can already, I've already given the example, you can observe. Similarly, the next characteristic would be, property would be, the members of a homologous series have similar chemical properties. See, as I already told you, if you take methane, you take ethane, you take propane, butane and so on, they all can give rise to substitution reaction. Okay, if I take an example. So in this way, we can observe that each of the homologous series will have similar chemical properties. In the next slides, I will be telling you about homologous series of alcohol, aldehyde. So there we can understand how every homologous series of alcohol behaves in the same pattern. Okay. Now coming to the last characteristic of alkane, the members of a homologous series show gradual change in their physical properties with increase in molecular mass. See, I have given an example. See, boiling point of methane is minus 161.5 degrees Celsius and boiling point of ethane is minus 89. So there you can see that there is decrease in boiling point. Okay, so I mean to say there is increase in boiling point. Of course, here it's negative value. So minus 161 is less than minus 89. That means ethane is having higher boiling point than methane. Similarly, if you want to talk about density also, you can observe that ethane would be having higher density, more denser than methane. Similarly, melting point also, the higher homologous series will be having, homolog will be having more melting point compared to the previous homolog. Okay, so this is all about the characteristics of homologous series. Thank you.